To test hypothesis, you need to formulate it first. For example, we have data for movies rating, and our hypothesis is will the rating be 3.5? Next, based on the theoretical knowledge, we choose which test to use. Do you know the population standard deviation? If you have data like we have, we can always calculate standard deviation. So, yes. Then we'll look at the size of your data, if it is more than 30 or not. In our case, the rating count is 53. So yes, it's more than 30. Then we use the z-test. Next, you start calculation with creating mathematical model based on your word statements. So hypothesis H0 is your assumption. You want to test if it's possible that the mean would be 3.5. Next, you calculate the real mean, average of the data column A. Next, you write the size of your data is 53. Next, you calculate the standard deviation, sigma. Then you calculate real statistical value using the formula. Then you choose the alpha. For example, if you want to answer your assumption with 95% probability, you would choose 5% of alpha. Next and final step before making a decision is to calculate the theoretical critical value, with which we compare the real value to decide our hypothesis is okay or not. We test one concrete value, and in our case H1 hypothesis, when mu is not equal to mu 0. Our critical value is 1.96 and statistical value is minus 1.343, and it's inside of their region. You can see it over here. So that's why our decision is do not reject H0. To confirm the calculations, we check this decision with another technique, p-value. We use our calculated statistical value, we know the alpha, and then we calculate the p-value. In our case, z is negative, and we use ABC over here in our formula, and p-value is 0.19 if we will round it to 2 digits. Our alpha is 0.05, and based on their theory, the p-value is more than alpha, so we do not reject the null hypothesis. Do not reject H0. And we see that the both methods are given the same result. So in summary, the decision is with 95% probability the rating can be 3.5.